Yes.
CR2.
CR2G.
CR2SO4.
CR2
Brackets.
SO4 bracket 3. So chromium in charge of G by looking at this. SO4 is what? It's 2 minus, isn't it?
Yes.
So in charge of 3 chromium 3, isn't it? 3 plus, isn't it? Okay, so what's the question?
We're mixing allowed to
We were mixed. Okay.
to come to equilibrium. Construct an equation in oxidation and calculate the E cell, E beta cell.
Construct an equation. These 4 were mixed. Okay. I guess we need to think about what are these things. There are some common oxidizing agents that we know about.
Yes.
I'm tempted to read the question myself. Read again.
Acidified solutions. 1 mole per gm cube, potassium manganate 7, manganese 2 sulfate, potassium dichromate 6, and chromium 2 sulfate. We mixed and allowed to come to equilibrium.
Yes.
Construct an equation for the overall reaction and calculate the E beta cell.
Okay, how do you tackle this? What do you think? Okay, firstly, what can you recognize? Chija ukuziva about chinoita basa pama chemicals. And you must be able to pick something. I know this. I know what it does. And so I told you, yes.
Oxidizing agents.
Oxidizing agents. And
Potassium.
This one, potassium manganate. And what else?
Potassium.
Your dichromate. These are oxidizing agents. And
Yes.
very popular oxidizing agents and powerful oxidizing agents. So I guess this question is about feasibility. Which reaction is going to take place? Can potassium manganate, for example, oxidize this compound here? Can it also oxidize this compound? Which reaction is going to be feasible? Unfortunately, if we do not have a marking scheme, we might have to confirm later. But it's about if you are asked if they were mixed. Remember, when you mix things, it doesn't mean that everything in the mixture is going to react. So, no concept of feasibility, which reaction is going to be feasible. So, you might want to test, can this oxidize this, for example, and or can this oxidize this? And it should. I would suspect that this dichromate, let's start with this combination. Can this oxidize this? How do you do that? Go and look for an equation of this, a half equation of manganate 2 plus. Manganate 2 plus and its E theta value. And check whether there is going to be a feasible reaction with this dichromate. And can this oxidize this? My choice is based on I'm trying to avoid a compound with manganese trying to oxidize another manganese compound. This is why it's E versus E. E versus E. And this one is an oxidizing agent itself. Let's see if that is feasible. And those combinations. We have to have one of these being feasible. This versus this. And this versus this. That's the score. You might come up with 2 equations, 2 feasible reactions, and then unogona combine aiwa. Ushaza zvezve kuti kana pane spectator ions, you cancel them out and come up with an overall reaction. And if you are lucky, there's going to be one possibility only one equation, one reaction is possible. Yeah, like only one is possible, isn't it? And that becomes your overall. If you're going to come up with two reactions that might possibly occur, you are going to be forced to combine those two into an overall reaction. You know it, isn't it? You have two reactions taking place at the same time. You can try to combine them and see if there are spectator ions that you might cancel out and remain with an overall equation, isn't it? That's the scope. It can't be anything other than this. Saka, for the sake of time, before you try it, to discuss. Put your brother, for example, I was already. My interval is to my head, to look for this whole balance and electrons and then. So for the sake of time, so maybe it's not anything further from that. When you mix several compounds, you can test which ones are going to react using electropotentials. And then, when you see the ones that are going to react, you can combine their equations into overall equations. Yes. So, and then to discuss. And then, which ones are going to be oxidized by these oxidizing agents? And then, okay, can we move on to something? So, good one. Next one. Anything else? I think we should be. Let's end in 20 minutes. Are you okay with that? Nominate. Let's end in 20 minutes and let's have other questions, other areas. Let's have areas, gray areas. Or passing some questions. When we were studying, maybe something didn't make sense. Yes.
November 2009.
November 2009. Paper 2. What's the question?
During electrolysis in a diaphragm cell, hydrogen, chlorine, and sodium hydroxide are produced. Then sodium
during electrolysis of what? Of what?
brine.
Okay, brine. Let's quickly rush to that diagram, to that electrolysis of brine. Let's quickly rush to the diagram. And as you can see, this electrolysis of brine in ODY, isn't it?
Yes.
So you have the diagram and the equations with you. Isn't it? Yes, what's the question?
The first question is deduce the overall equation for the electrolysis of brine.
Deduce the overall equation. So we need two equations that are taking place there. How many equations are taking place? How many reactions are taking place during the electrolysis of brine? Then you combine this into an overall equation. But how do we eat it? I remember she eat a question, isn't it? The overall equation, what are the two equations? I don't know how many equations are there during that are per diagram range for a electrolysis of what? Brine. My questions are in purple. We need to combine them into an overall equation, isn't it? This one is workable, isn't it? Which means I'm overall. Let's write the two equations and combine them, isn't it?
Yes.
Yes. Let's do that one. So electrolysis of brine, please go through the electrolytic cell. What is going on? Isn't it? Here can I take my page? As 180 what? 182 of 108. So you can just check on that. Maybe combining the equations. Won't get a problem. Or you just have to memorize. What are the question you have to give?
Deduce the overall equation.
You have to deduce. So what are you giving? You got to deduce. What am I giving by the question? I'm deducing from what? Other people have the question.